Welcome back to another explainer. I am incredibly thrilled you're here because today we're basically entering the matrix of mobile app debugging. We're going to put on our senior engineer hats, seize total control of the network layer, and finally prove once and for all that yes, it actually is a back-end bug. If you've ever felt completely blind when an app just decides to misbehave, you are absolutely going to love what we uncover today.
So picture this scenario. You're testing a mobile app. You tap a button to sync some data, the little loading spinner freezes for a split second and then nothing. No error message, no toast notification. The whole thing just silently fails or crashes outright. Now, if you were building a web app, you just pop open your browser's DevTools, right? Easy. But browser DevTools literally cannot save us here. We're dealing with a compiled native mobile app. The failure is completely invisible to the naked eye. So how do we actually find out what went wrong? Okay, let's dive into this. On one side, we have our Android Studio emulator. To the user, it's just a sleek, polished interface that is, well, currently broken. But under the hood, that's the network layer. That is the hidden truth. We're going to use a specific tool to strip away that shiny UI and expose the raw data flowing between our app and the back-end servers. Basically, we're going on a bug hunt. To see that hidden truth, we need Charles Proxy. At its core, Charles is a web debugging proxy. But to be more specific, it acts as a man in the middle. By securely positioning itself right between your Android emulator and the internet, it captures every single HTTP and HTTPS request. It intercepts the data, decrypts it so we can actually read it, and, here's the kicker, it even lets us modify that data before it reaches the server or comes back to the app. All right, so how do we get this superpower? We have to invite Charles into our device. Setting this up on an Android emulator requires a very specific sequence. First, we point the emulator's proxy settings to 10.0.2.2. Actually, make sure it's on port 8088 too. That IP address is a magic loopback address in Android emulators. It points directly back to your host computer where Charles is running. Next, we open up the emulator's browser, head over to chls.pro/SSL, and download the Charles root certificate. And finally, Android makes us set a device lock PIN before it'll let us install any custom certificates. But getting the certificate onto the device isn't quite enough for modern Android. Since Android Nougat, apps are locked down tight by default. They absolutely do not trust user-installed certificates. If you skip this step, your app will just reject the connection entirely, no questions asked. So inside our app's codebase, we have to create a network security config XML file. This explicitly tells our debug build to trust user certificates. Then, we just reference this file right in our Android manifest. It's an absolutely vital security bypass, but specifically just for our local debugging. Now, here's the crucial point. Even with that certificate installed, Charles won't magically decrypt the traffic unless you explicitly tell it to. Inside Charles, we have to go to Proxy Settings and enable SSL Proxying. Without toggling this on for our specific host, or just using a wildcard asterisk for all hosts on port 443, every single HTTPS request will just show up as unknown binary garbage. And you can't debug what you can't read, right?
Okay, so once that encrypted traffic is actually readable, you'll see Charles start populating with data. To prevent total cognitive overload, Charles gives us two main ways to view this absolute fire hose of information. The Structure tab organizes everything into really neat little folders based on the domain name. That's great for exploring an API's overall architecture. But then, there's the Sequence tab. This lists every single request chronologically right as it happens. For our active bug hunt today, this Sequence tab is exactly what we need to watch events unfold in real time.
All right, our trap is set. We're monitoring that Sequence tab. Let's trigger our scenario. Over in the emulator, we initiate the background token sync. That's the exact action that caused our silent crash earlier. We watch the UI do absolutely nothing, but over in Charles, the network traffic is lighting up. And suddenly, we catch our culprit. Boom! Right there in the Sequence tab, flashing with a giant error icon, is an HTTP 401 unauthorized response. The app's user interface completely swallowed this error. It left the user, and honestly, the developer, completely in the dark. But Charles Proxy caught the network layer red-handed. The back end is straight up rejecting our app.
Now, what's really interesting about this breakdown is the anatomy of the failure itself. By clicking into that failing request in Charles, we can inspect the payload. We see the app tried to hit the auth refresh endpoint. It got that 401 status. But look at the JSON payload returned by the server. It says invalid_grant. This tells us the user's refresh token either expired or was revoked. But clearly, the mobile app's code has zero safety net to handle this specific JSON response. It doesn't gracefully log the user out, it just silently crashes the background sync process.
So we found the bug. Awesome. But how do we actually test a fix? I mean, we could wait for the backend engineers to manually change our test user's token state, maybe shoot them a Slack message and wait 3 hours, but that totally kills our momentum. Enter the rewrite tool. This is arguably Charles Proxy's single most powerful feature for front-end developers and QA engineers. It lets us intercept that 401 response and automatically rewrite it into a successful response, right on the fly, before the mobile app ever even sees it.
Setting this up is incredibly satisfying. Trust me. We go to Tools, then Rewrite. We create a rule that strictly matches the URL path of our failing auth endpoint. We're basically telling Charles, hey, when you see a response from this URL, modify the response body. Then we just paste in a perfectly valid mock JSON token payload and literally force the status code to return a 200 OK. And this brilliantly illustrates why having a man-in-the-middle proxy is basically like having a superpower. Let's trigger that exact same sync in the emulator one more time. The real server still replies with a 401 error, but Charles catches it in mid-air, rewrites the payload to our mock valid token, and hands it to the app as a 200 OK. The app happily accepts the mock data, the UI updates beautifully, and the sync succeeds. We've just proven exactly how the app should behave when it receives valid data, entirely isolating the front end from the back end. We solved our silent crash, but honestly, this is just the beginning. When you unlock this level of network visibility, the polished UI just fades away, and you see the true behavior of your software. Like our third-party SDKs sending your location data in plain text, our undocumented shadow APIs bogging down your startup time. I highly encourage you to set up Charles Proxy, point your emulator to it, and audit your own applications. You might be very, very surprised by what you find hiding in the dark. Thanks for joining me on this explainer, and happy bug hunting.